Welcome to the Threat Intelligence section of the Microsoft Cybersecurity Reference Architectures. My name is Mark Simos, Lead Cybersecurity Architect at Microsoft.
And I am James Ringgold, Chief Security Advisor at Microsoft.
So we thought we'd start off by kind of showing the value of threat intelligence and what happens when it works well. And this doesn't happen in every single case, but this is a really good example of what we're trying to make happen as much as possible every time. So what happened in this particular case, Midwest of the United States, a high school teacher got the very first copy of a brand new banking Trojan, new variant of an existing Emotet banking Trojan. And he never actually knew that this happened because the threat intelligence took care of it, along with machine learning, sometimes referred to as the bigger picture AI, but ultimately the machine learning technology underneath. And so this particular person clicked on an attachment that was in from his Gmail account in the built-in Windows Mail app that was on his PC. And before that could ever actually open, there was a bunch of things that happened. It was scanned locally. It was detonated on the cloud using the machine learning piece to scan for that, to check the behaviors and what it would do. And then using all of these signals, etc., the mail was deleted, removed from the account, and it was also flagged for human review so that someone else could confirm it, a human analyst at Microsoft. And all of this happened in less than 400 milliseconds. And so this person was protected from the first version. We're not talking an extra copy of something there's already an antivirus signature for, but within 400 milliseconds, this person, and of course, confirmed after that, everyone else that got that variant was protected. And this is really what happens when threat intelligence works ideally. And again, this doesn't work in every single case, but it is an example of what happens and when it works well, and what we're striving to make happen in every single case. Anything to add, James?
Yeah, I mean, the speed of the effectiveness here, the way that it was detected, detonated, and then prevented from being opened by the end user is really the key pieces to what we're striving for with threat intelligence. It's something where everyone believes threat intelligence is a bunch of information about bad stuff happening, whereas as we've progressed over time, we've really had to leverage things like artificial intelligence and fully automated protection and build into that platform to really protect people from things that could go wrong.
Yeah, because at the end of the day, it is about outcome, right? The whole point of this is to protect against the attacks and make it more expensive for the attackers to attack so that they're less successful at it overall. So
Microsoft leverages the signals that we get from incidents like that to generate those threat intelligence signals and security insights. Now, everyone asks us, can we get access to this vast array of threat intelligence information? And really, due to the amount of signals we get, trillions and billions of signals and predictions, we use that information to train artificial intelligence and the machine learning models so that they give us an advantage against the attackers. They allow those sub-second response times, and they allow us to really block attack attempts before they can become successful breaches.
yeah, and because I think our current rate, last I checked, was about 8.5 trillion signals a day that we take in that give us that overall context, which of course we have to process down into the billions level and the millions level. But the one thing that we have learned over the course of doing this for many years is the volume of threat intelligence is important, but so too is the diversity. Because Microsoft, by virtue of the businesses that we're in, we're an antivirus provider, and we're also a email provider, consumer and professional. We have endpoint detection response. We've got authentications. We've got all sorts of cloud storage and activity. And we found that the ability to correlate those different signals together is actually one of the huge success factors. So, James?
Yeah, I want to talk about the diversity, right? There's over 1.2 billion PCs and servers and IoT devices that run Windows, and everyone thinks we get the threat intel from there, but we also have hundreds of millions of iOS and Android devices and Mac and Linux endpoints that are accessing Microsoft services or using Microsoft software. Then you throw in the additional billion users of Azure Cloud Services, and the diversity of that threat signal really becomes important. It's not just the volume of signals, right? It's the transactions that happen, the identity transactions and the emails, the blocked attempts to access different properties of Microsoft, but also our customers as well.
Yeah, and one of the ways that I like to think about it is if you're trying to capture a picture of a unicorn galloping by, you want to have as many different kind of cameras because it's a rare and difficult to capture event. And one of them might pick up the hooves and the hoof prints. One of them might pick up the horn. One of them might pick up the mane, and the other might pick up the tail. And just having one of those signals, you're not quite sure what it is. But if you have all of those, you have a better chance of capturing it and getting that picture. But you also get a bigger picture when you put them all together to say, this isn't just a thing that happened on the network. This is a thing that involved this and was connected to this and correlated and was in the same time frame as this. And you can really pull that picture together. And that's really where the diversity kind of comes through. So when you dive into like the technical details of how does all this work. So ultimately it's a process, right? And this is how all of these things are wired together inside of Microsoft. So the first part is that product and service telemetry, that raw data that comes in that we were just discussing. But that's not all that we use for threat intelligence. We have an incident response team that's regularly responding to major incidents at our customers and helping them recover from it, whether it's ransomware or nation state attacks or data theft attacks, et cetera. We have specialized detections around detonations and sandboxes to get information there, sinkholes and honeypots from some of the law enforcement actions that we've assisted with botnet takedowns and the like. A bunch of external threat feeds as well, so we don't just limit ourselves to our own data. And we also do first-party dark market research on what's happening, what are the trends that are going on, what's being bought and sold on those criminal forums where, in terms of malware and 0 days and username password pairs and the like. And of course, sample zoos, right? Because we're an antivirus provider, and we're in the neighborhood of, last I checked, I think it was around 4 or 4.5 trillion files in our sample zoo because we've been doing this for so long, and that's a scale that's very rarely seen in the industry, if at all. And so all of these signals get then processed through a privacy compliance boundary because Microsoft, quite frankly, is one of the most regulated companies from a security compliance perspective on the planet because we operate in so many different jurisdictions. So we have to meet just about every security compliance regulatory requirement or framework that you could imagine or see. I remember the early days of the cloud, the icons on the slide just kept getting more and more dense, and then they get to summaries, and then it's just like, okay, here's the total number, because it just got silly. But ultimately, all of those things tend to be roughly similar, but we have to make sure that we're meeting all of those before we ever use this data. And so if someone didn't give us permission to use that data, we cannot use it, period. And so that's one of the key things, is that we are very, very careful about that. So the next step is, okay, we need to now do the data collection analysis. We need to get the insights out of this. So we have to go through the collection normalization, make sure we're correlating them together and connecting. This is where a lot of machine learning, which is really woven throughout this process, gets done. And machine learning is basically probability at the end of the day, mathematical probability, and it helps you identify, okay, this is the norm, and here's an anomaly, here's a variation or something unusual from that norm. So we apply a lot of different machine learning in different ways, as well as behavior analytics to, instead of looking at and saying, is this an unusual network connection? We can say, is this an unusual network connection for this user for this time of day? Because we can profile those behavioral analytics. And of course, we have internal APIs that we then publish this to, because this isn't a single system, but it acts as a single system. So each of these things are specialized, and then they're interconnected together. And that's kind of where the magic happens, where the different technical capabilities, like Azure Sentinel, Azure Defender, Defender for Endpoint, Defender for Identity, Cloud App Security, all these various different product capabilities then consume that data and use that so that when they get an alert, okay, is this something that is a known false positive somewhere else? Okay, then we can go ahead and cut it out. Is there something else that we know about this that, hey, this might relate to this, and these things are connected, and either we have the confidence of the machines, or we have to bring in an analyst to confirm that. And so all of these things kind of consume that data, and then their learnings enrich that data and continually make it better and better. Anything to add, James?
Yeah, I mean, to be successful with threat intelligence, really, it requires that large data set, and it has to be a diverse data set, as we've talked about. And everyone focuses in on more signal, more signal, more signal. And what we really fail at is applying that data to our processes and tools, right? So whether you're leveraging a Microsoft platform or another platform, that application of the threat intelligence, that diversity of data, is what really enables the hunters and your security operations team to leverage that intelligence. It's not just about collecting information and signal. It really is, how are you going to use it? What are you going to use to create and tune and validate analytics and really improve your detection? And that's what threat hunting really is all about. Threat intelligence really tries to drive.
100% agreed, because if it's not making the alerts better and filtering out the garbage and highlighting the ones that you need to pay attention to and helping build that full picture, that common operating picture, it's not really helping detection. If it's not helping you with the investigation and really understanding it to guide you through it, it's not really adding value. Just having the data, the old expression of collection is not detection, really applies here, that you have to be able to get value out of that. And then the last stage here, before we kind of close this up, is the human factor. And we have, I think the last number we published on this was about 3,500 security professionals, probably much more by now because that's a few years old, that are focused on security at Microsoft, many of which are doing things like data science and tuning the machine learning. Because machine learning, saying you have machine learning is like saying I have nails in my house. Great. How did you use them? Did you pull it together? So it's really about, again, that application. And so, they're tuning that machine learning. The data scientists and the security subject matter experts are working together to bring those two disciplines together. They're tuning the heuristics, the sort of the rules, and that are a little bit more manual, and other pieces and queries, and doing research on this, and hypothesis-driven hunting, running machine learning in an unsupervised mode to say, okay, what's happening in this data that's clustering up or unusual that might indicate that there's a security thing going on, or a nation state that figured out something that we haven't seen yet. And so we have a lot of those folks working and learning from the latest incidents and the latest ransomware variants, and can we add a new feature in, and kind of influencing those products, as well as enriching the data and the insights from it. So James, any final thoughts as we kind of close out on kind of how this system works?
Yeah, last thought is, threat intelligence is a cycle, right? It's not just a feed that comes in. It's something that gets refined, right? Analysis and hunting really looks at things as what's of value, what's not of value, and what's really important in your environment. What could be important to me as a manufacturer might not be the same that's important to a bank or a financial institution. And so really making sure that you understand the diversity and understand how that threat intelligence is applicable, and then how you're going to use it, is really key to making it of value.
100% agree. It's got to, at the end of the day, lower your risk, your business and your mission risk, and it's got to do that by helping with those specific security processes and making them better, faster, more efficient, or more automated. So with that, thank you, James. Really appreciate you joining me here, and thank you all for watching.